Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. We also have a special guest, Gary McCready from HVAC Know-It-All. How you doing, Gary?
I'm doing well tonight. How you guys doing?
We're doing all right. Kev, how you doing this week, man?
Freezing cold.
I was going to say, how cold is it up there in Chicagoland?
It was a -2 this morning in the city on the roof at 4:30
Nice. What are you working on this week, man?
doing Danfoss changeovers. So I'm so thrilled.
He's been dealing with a headache for the past, just 2 days, but he's been loving every minute of it.
So
What do you Dan Foss what? Switching over what, Kevin?
we're going from like old 1992 RMCCs to basically Danfoss 800 days.
So RMCCs, Gary, just so you're aware, are basically are older CPC controller, and then he's switching over to something that kind of looks like this.
Okay. And that is to control what exactly? Is that to control an entire system? Part of a system?
Yeah, it basically controls everything in the entire store. So it controls
Yeah.
everything, the compressors, the fans, to the some of them, the heat, the cooling, controls basically everything. It's like the whole, like, brains of the store, and it's basically running an IO network, meaning, like, it has separate boards that it's slave commanding to do whatever task it needs, whether it be defrost, refrigeration,
Yeah.
whether it be turning fans on and off.
Are you
So,
doing the lights and shit? Are you doing the lights and all the HVAC with the Danfoss?
yes, unfortunately.
Wow. So we used to do controls too, like at the company I used to work at. That was reliable controls. It wasn't refrigeration though. It was for basically HVAC stuff. But we wouldn't get into controlling lights. So you guys are controlling lights in the supermarket well with that stuff.
Yeah. Typically, the way it works is we control it over two methods, right? We'll have a set schedule. So let's just say the lights are scheduled to turn off at, I don't know, if like it's 7 a.m., but there'll also be a backup in there where it'll go off a photocell. So if the photocell senses a certain foot candles, it'll actually shut off the lights before the time. And the same thing with it turning on the lights. Like the light schedule might be on, no, we're going to turn it on at 5 o'clock or 6 o'clock, but then we're both those statements have to be true. So the schedule has to be true, but also the cut out for the light or the cut on for the lights also has to be on. So like once it gets down to about, what do we usually set them for? 20, 25 foot candles, Kev,
Yeah,
for,
but
for a cutout. So basically when it gets, when it gets that dark, because when you have if you shine a light on a photocell, it'll show freaking 800 foot candles, right? Like if you just
Mhm.
take a flashlight to it, but if you cover it up with a piece of tape, it should go back down to zero. But usually about 20 to 25 foot candles is usually where we knock shit off or turn the lights back on. I'm sorry.
Yeah. This is way more in depth than I would ever get into refrigeration because I don't do supermarket racks, none of that. I've done pharmaceutical stuff, smaller applications, and the biggest controller I've seen or the most complicated one I've worked with is the Honeywell T775, which I like, but I mean, that's the extent of controls that I get into with refrigeration. So this is
Wait a
crazy
minute,
to me.
is that big gray box with the red screen that has a couple
Correct.
buttons?
Yeah. Yep.
Okay,
Yeah.
we
Yeah.
deal with
You can
them on the
control
blood banks.
Yeah, you can control it, boilers with those, pretty much anything you want, but there's been a lot of pharmaceutical applications where they've chose to throw those onto the, into the control box type thing, right?
And that's what Kevin basically does. He's that and a firefighter, right?
yeah, I guess I would like this store to catch on fire.
I'm sure
Happening.
I'm sure we've
Happening.
all got customers we feel that way about, Kevin.
Oh, this may be like one of the worst stores we have. Like,
They're having to put on VFD drives on condensers that are how old, Kev?
not at this store, but there was another store where it was almost 30 years old. There's one of them I think that's gonna get stopped. But this store, I mean, we're doing drives at this store, and their sprinklers are on at 50 degrees.
That's awesome.
Do you mind
So
if I
get
ask you do you mind if I ask you guys something along the lines of low temp refrigeration?
Sure.
So, this is pertaining to superheat because, Brett, you brought up superheat earlier when we were talking before you hit record, and some of the stuff I used to take care of was, would you consider minus 40 degrees Celsius low temperature application? So
Yes.
minus 40, C and F line up together, so it doesn't really matter.
So here's the weird thing. So if you look at a Sporlan power head chart, right? Negative 40, I think, is the end mark for a Z charge,
Mhm.
because you have different charges, right? You have C is commercial, which is I think 50 to negative 10. Then you have GA, which is general application, which is like chillers and air conditioners and shit like that. Then you have Z charge, which is 0 to negative 40. But then you have X charge, which is extremely low charge, which goes from negative 50 to 100. So it's like kind of borderline, like what it's actually considered. But I mean, typically, like on the blood banks and stuff that I've serviced, they usually typically have Z charges on there, so it's considered just regular low temp.
Yeah, and this was blood plasma that they were storing in
Mm-hmm.
these freezers, right?
Mm-hmm.
And it was for pharmaceutical purposes. And what I wanted to ask you about was the superheat that you would see at the compressor on a system that runs that low, that low of a box temperature. Because there was a couple I would work on that were side by side on the roof, and when they were working normally, we were getting anywhere between 60, 65 degrees of superheat at the compressor from like all the way up the piping, outside a bit, and right at the compressor. And these things would run, they would cycle, they would hit set point. Are you
Mm-hmm.
guys seeing high superheats on low temperature applications with longer pipe runs like that?
How long are you talking?
I'm talking like 50, 60 feet, maybe 75 feet.
Hmm. Kev, what do you think, man? I mean, because usually on low temp, it's weird. So like on any low temp thing, I usually see 3 to 5. But like if you talk to some of the guys that run the blood banks, they'll say that they want like a 6 to 8 degrees superheat. Which I mean, if you're getting 65 back at the pump, dude, I'd
That's
think
a
that
lot.
your insulation is messed up, or your superheat is way too high. What do you think, Kev?
I mean, to get 65
At
degrees,
at the compressor, not evaporator, at the compressor
Yeah.
itself. Yeah.
and they had like, I mean, 60 feet of line is not that much. So I mean, it shouldn't heat up that much unless the Armo is just like completely toasted.
Yeah.
Yeah, I don't like, I mean, we work on, bakery boxes that are all the way the hell in front,
Mhm.
right? That are 200, 250 feet away. And you said that thing to 3 to 5 degrees of superheat, you're getting maybe 10, maybe 15 degrees back at the rack.
Yeah.
So I don't, that seems awful high.
Yeah, well, they were running, both of them were set up the exact same way, and they both ran by the like, they were redundant systems, right? It was one box, 2 systems redundant of each other, either one could run and maintain the box, and both were running the exact same way. And for maybe, I left the company back in May, but maybe for 10 years at that point.
Yeah.
Yeah.
Huh. I mean, that just seems awfully high. You know what I
It's
mean?
a no, it's high to me too, very high
Because,
to me.
well, typically, like what a Copeland, if you look at a Copeland guide, depending on what compressor you're looking at, typically you have 20 degrees of superheat at the compressor, right? That's minimum. That's to
Mhm.
make sure you don't get any flood back, going to that compressor, any rich kind of superheat. And then there's usually a max temperature of 65. You know what I mean? So like think about air conditioning, right? That's something you're real comfortable with. So you typically run anywhere from a 38 to a 40-degree saturated, right?
Mhm.
And if you get 20 degrees on top of that, you're looking at 60 degrees, right? Which is about what your suction line temperature is going to be at your condensing unit, right?
Mhm.
So even at a real high load where it's real hot that day, you might have like 42 or 43, which still brings you underneath that 65-degree line temperature coming back. Because otherwise you're going to work outside the operating envelope and that compressor is going to overheat, and either the module is going to open up in the compressor or the three phase is going to.
Oh, yeah, I totally agree, but I just found it bizarre both of these systems ran that way, and they ran like this for years. The suction line was still ice up. I mean, we were running at, I think it was 404A, and we were running at, geez, I don't have a PT chart in front of me, but I mean, we're running down at like 6, 7 PSI on the suction side.
Which is like negative 40.
Mhm.
It's right about negative 40. So if you're running 32 degrees, I mean, that's 72 degrees of superheat, right? Like, cause ice, you have to, in order to have ice, it has to be at 32 degrees, right?
Yeah, that's right, yeah.
I
Yeah.
bet you the Armoflex is just like full of water and ice. It's
It
just
could it could be it could be f you might be right on that, Kevin. It might be just filled with a lot of water because as it was going up, once in a while, they complain about drips coming down below the piping, and there was no way to get at it unless you got a specialized genie boom in there because it was going up against the back of a bunch of boxes that were lined up together, and there was really no way to get back up there without a special genie boom. But since it was running, it was maintaining, all the alarms were kept in check, it wasn't really an issue for the facility at that point. But I just thought it was interesting. And these compressors were scrolls, and they were outfitted with liquid injection. There was like a it was like a
ETC valve.
mechanical it was a mechanical device, right? And it had like a there was a well in the compressor, and it was there was a temperature probe that went into the well, connected to a mechanical device that would liquid inject into the scroll compressor.
Yep.
Yeah.
Yeah, it's those are called the PC valve. Discharge temperature control, I think maybe what it's called. But essentially on that particular one that you're talking about, that goes directly in the top of the head.
Yeah.
You have to be really careful with those because a lot of times people will change compressors. They'll grab them on with a channel locks or whatever. When they do that, they basically crush the ball. If they crush the ball, what's going to happen? It's going to push that valve a little bit farther open, right? And then cause that thing to feed when it's not supposed to, and then it then ends
Mhm.
up grenading the compressor because the
Yeah.
thing thinks it's hot, but it's
Yeah.
not. And then you're just basically forcing that valve open. So if there is any liquid in that line, it's literally turning it on a liquid start.
Yeah. No, good point. No, very good point. So that's really my extent of refrigeration is small pharmaceutical applications that stored I mean, you could have a walk-in box that was 20 by 15 or 15 by 10 or something small, and you could have $5 million worth of product in there. So and these things weren't very the equipment wasn't very big, right? We're talking about small equipment here to keep these things cool because we're not talking a large amount of product. We're just talking about very expensive product. So it was really weird living it was kinda like being in the supermarket realm a little bit, but we didn't get nearly as many calls as a supermarket would because I have a friend in the supermarket, and every time he's on call, he's gone all weekend, every single time.
Kev, you run service along when it gets slow, right?
well, I mean, pretty much every day after I'm done with my 8 hours, I pretty much run service.
Yeah.
So I mean, yeah, I mean, there's always calls. I mean, I think we're backlogged for like 2 months probably, and it's almost February.
The parts thing is killing us. Like as far as getting calls closed and stuff like that, I don't know. I mean, you do predominantly residential, correct? Residential, like commercial, correct here?
I've been doing a lot of residential lately just because I started my own one-man show, and that's where the cash flow is right now.
Yeah.
But I've been teetering between residential and commercial over the last 8 months or so.
Gotcha.
And yeah, the parts thing has gotten everybody. I think the supply chain has failed a lot of people, and it's just something we have to deal with. There's a lot of room for universal type parts these days, if or aftermarket parts if they're available to use because the OEM hasn't like Carrier, for example. There's some parts for Carrier rooftop equipment that's been on back order for over a year, right? And like, what do you do?
Man.
What do you do at that point if the part has actually failed? I mean, you have to come up with some other way to provide the customer with some sort of air, whether it's heating or cooling, right? It doesn't matter what part of the industry you're in. If you're missing a part in refrigeration for a rack or a grocery store and that OEM's on back order, what do you do? Like, how do you guys deal with that? I should ask you that question.
I mean, a lot of MacGyvering and
Yeah.
hoarding, a lot of hoarding. Like, I mean, my entire office is full of like spare parts and used parts and stuff we take off. It's like, that's good. I'm gonna keep it. Like there's a lot of that. I mean, other than that, like we have just gotten absolutely hosed by like the supply chain stuff. Like for like construction stuff, cases. I mean, there's times where we're waiting weeks for cases to show up. They're supposed to show up, they don't show up. Well, now it's costing us a ton of money. And then when they do show up, it's like, oh, now they're overlapping 4 other jobs, and now we're again.
Well, not just that, Kev. Where you told me like there was stuff coming in without stuff. Like,
Oh yeah, like cases half put together, racks with components missing. Like I'm waiting on VFDs for a store we finished a year ago still.
Wow.
the
The
evaporator
manufacturer has shipped them twice now, the wrong voltage.
evaporators coming in without actual fans or fan guards. So they'll hang them, right? Because the construction job has a certain set that has to go first, right?
Yeah.
Box gets built, the coils get hung, then they get piped. Shit gets piped, shit's all ready to go. It's like, well, can't start it up. Well, why not? No fan blades. Well, why not? They're on back order. What do you do?
Yeah. So is that so do they give you guys a heads up that it's coming with no fan blades, or does it just
No,
show up that way?
90% of the time it just shows up that way. Like
Yeah.
no warning. It's just like, no, we better not tell them because they're gonna get mad.
Tell okay. Can you say there was a fucking IOU on it?
There's IOU inside all these cases, like IOU 64 shelf clips, like I'm like, it's like this controller.
At
Okay,
least, at least with like residential, I don't think you get any condensing units that, hey, we're missing a board. We'll get you that next week.
Man, the IOU thing you just hit home with me on that. When I was a kid and I used to get paychecks, I'm gonna tell you this is not work related at all, but it was just funny. I forgot my check and I was going out with my buddies and I forgot my check at home. So and I usually put it in the bank machine and then it would spit the cash out after. So I wrote an IOU for the amount of my check on the paper and I put it into the bank and I took the money out anyway, right? It was they went on a trust level back then, and my bank account got suspended for like a week after that. So, yeah, it don't do that, folks.
That sounds like a Canadian thing.
Yeah,
We're gonna
yeah,
trust you for a week.
yeah. Well, I mean, hey, I was gonna put the money in when I got my check, but I needed the money right there and then. Anyway,
Yeah.
it's pretty bad. Like, I mean, missing parts, wrong parts, half put together parts, components. Just yeah, missing components, half-ass components. I mean, everything's gotten cheaper too.
The longevity of some of the equipment is just not there anymore. And like a lot of it's if you really think about it, it's the Department of Energy because they'll put stipulations. Like, so I know you guys are probably definitely dealing with this up there in Canada where they say it has to save this much energy, right? So
mhm.
they'll oversize units and then they'll run the head pressure all the way down. And then basically the condenser is now the compressor is way oversized. So it brings the suction pressure all the way down. And then it ends up causing failures because the suction pressure is too low. And it's an ongoing cycle. Well, it's supposed to run. Well, it's oversized now. So you have to kind of manipulate the numbers in order to get it to function right.
Interesting.
It's yeah, it's a numbers game. It's because if you like, think about it, if you have a condensing unit that's running at 120 degrees saturated, right? And you
Mhm.
jump that thing down where you lower the head pressure all the way down to 75 degrees saturated, that compressor now has increased capacity by anywhere from 25 to 35%. Okay.
Mhm.
So now the compressor is way bigger. So what's going to happen to your suction pressure?
Are you
Right?
asking me?
Yeah, I'm asking
Oh,
you.
sorry. I didn't know you were asking me. Sorry.
No, you're fine. You're
Yeah,
fine.
no. Go on. Explain because
So
I'm just absorbing this.
no, you're fine. So if you have a compressor that's bigger than what it's supposed to be,
Yeah.
what's going to happen? Your suction pressure is going to be lower, right?
Mhm.
And unfortunately, the way things are sized, right? They usually go off the TD, the temperature difference between the saturated versus your discharge temperature. So
Yeah.
most of the time when engineers size shit, they'll size it for a 10-degree TD. So what'll happen is if it's sized for a 10-degree TD and it's a 1-ton coil, you're going to need a 1-ton evaporator. But now if we're running a bigger compressor where our suction pressure is going to be lower, now our compressor is way bigger, which means our suction pressure is lower, which means now our TD is higher. Well, when you increase the TD, so if you go from 10 degrees to 20 degrees, now the actual evaporator coil is not sized for a 1-ton. Now it's actually sized for a 2-ton. So we have units out there that are supposed to be running a 6 to 8 degrees of superheat, but they can't do it because the TD is so high. So now the evaporator looks way fucking bigger, but the expansion valve stays the same size. So you're running like 30 degrees of superheat on something that's supposed to be running 6 to 8 just because of the way the engineering rolls. So if you were to, like example, like in residential, if you were not running a 38-degree saturated coil right? You run it all the way down to fucking 20 degrees. That coil is now increased size. So technically you would need a bigger piston or bigger expansion valve. And so what happens is you end up kind of causing ice ups and shit like that. And now you have to explain to the customer why this doesn't work. And sometimes it's just like, hey, that's the way it was designed, and there's nothing I can do about it. Where they should have did something to control the suction pressure, or have some sort of vapor injection to raise the pressure, because otherwise it's not going to function right.
Now you're saying the suction in this scenario, the suction pressure is lowered. Now, is that causing any problems with your oil return? Or are
Mm-mm.
you no?
You're still getting the same pull.
Okay.
You're still getting the same pull. You're actually in all reality, you're getting a higher velocity. And a lot of the systems we work on have oil separators anyway.
I was
Like, you
gonna
know,
ask you that as well. Would it matter since you've got an oil separator on the system anyway?
yeah, for the moment, yeah, you're still running the same velocity, if not even a little bit more. And as long as you have, because there's three types of separators that we deal with: helical, coalescing, and impingement screen. And the only one that's really volume based is the centrifugal. So as long as you have like a coalescing or a impingement screen, it should separate it no matter what velocity that you pull at. Typically, Kev, do you ever see any fucking helical or centrifugals on the single units at all?
It's some like really, really small separators, I think are.
Yeah.
I mean,
So, go
I
ahead.
hardly ever see separators in single units. It's pretty rare. Like maybe a plasma center or like something like that. Like, I mean, I hardly ever see single units with oil separators unless it's like something really big.
See, the problem is with heel or with centrifugals, you have to run a certain volume. So I know Kev's had calls, I know I have, where we have oil failure constantly on the rack. And what happened was it didn't happen until they removed, like, it took 40,000 BTUs off and put it on a new rack somewhere else.
Mhm.
So now you're running 40,000 BTUs less. Now you got 5 compressors, but only like 1.5 are running. Like one is running all the
Yep.
time.
Yep.
And then you have the other one running on either on a VFD or a digital. And if it's not running a certain amount of discharge CFM, it's not going to separate that fucking oil. So then the oil just basically passes through and goes down the line. And then all of a sudden, now you lost all your oil from the rack. All the compressors start going off on low oil. And then all the oil is out in the fucking system because the separator wasn't doing its job. The rack was intended for a certain amount of discharge CFM. If you don't have that discharge CFM, it's going to tell you to go fuck yourself and not separate properly.
Yeah. See, this is the kind of stuff that I am totally unaware of in the world that you guys are in. I wouldn't know to, oh, it's got an oil separator. Like, why isn't it separating the oil? I wouldn't know that running at a lower capacity at 1.5 compressors instead of 5 would cause that. I wouldn't know that.
On a centrifugal, yes. On a pingent
Okay.
screen, not so much. Not so
Okay.
much.
Okay.
Kev, what some of the things that you've seen with the impingement screen? What are some of the things that cause the failure for that not to separate?
I mean, whether the screen blows out, usually like 90% of the time, it's the screen blows out. So there's looks like a screen door screen in there and a cone. It's shaped like a cone. And basically what happens if a compressor breaks or pieces of valve plate break off and go through there, it slices through it like a knife. So once it cuts through the screen door, just like a dog running through a screen door, I mean, there's a giant hole now, and then everything's going through the hole instead of through the screen. So
Mhm.
cause it to separate. So like 90% of the time when I see that, it's a torn screen.
Yeah. And how often would that happen?
I
Often
mean,
or
it depends. I mean, if they have a lot of compressor losses, it's pretty common. But usually, I mean, that all those separators are getting ripped out, and they're either putting a centrifugal or a coalescent style in because they're just so much more efficient. I mean, the old style separator is only like 60 to 70% efficient. So, I mean, they don't do as good a job of separating oil as a coalescent or a helicoil do.
Yeah, coalescing. So I like coalescing the best only because basically, if the unit is sized, if the separator is sized for 35 discharge CFM, you could run all the way down to 2 discharge CFM and it would still fucking separate. Okay. But if you have a centrifugal, if you have size for 35 discharge CFM and you're running, is it 25% less, usually like 25% less, and after that, it barely separates shit.
Yeah, but I will say this, if you overload a filtered separator, a coalescent, it will not separate worth a shit.
Yeah, so there's a fine line that you have to play, and unfortunately, like a lot of engineers, like they'll take a rack and they're like, yeah, we can throw another 60 on there, but they won't do anything with the separator or they won't do anything with the condenser. You
Well,
know, so
most of the time, what I see on startup is it's all sized for max ambient. Well, everything in Chicago is sized for 110 degrees now. Well, we run that like for like 5 days. So you're designing equipment to run at 5 days of runtime when the whole rest of the year it's going to see 50 to 70 to 80 degrees. And now we're like way oversized. So, I mean, that's where like all those issues come in. I see.
and like
Like,
it's weird, Gary, because like so there is a difference between discharge CFM and suction CFM. So when we're programming a controller, right, to tell because we have to tell the controller what size compressor it is because the algorithm basically decides like, okay, so which compressor we're going to turn on based off how fast the suction pressure came up from set point, right? So if it
Hmm.
came up super fast, I might turn on a 20 horse. If it came up a little fast, maybe I kick on a 10 horse, right? And then so that's the suction discharge, suction CFM. But then the discharge CFM is off a totally different number. So it's actually off of fuck, now it's gonna make me look like an asshole because I can't remember. It's there's it's is it the difference, Kev, is it the difference between the suction and the discharge? And there's like some kind of chart that you have to follow to basically follow the discharge CFM.
correct. And, I mean, Westermeyer makes that sweet app that does it all for you.
Thank you,
So
Westermeyer.
you just put all your parameters in there and it'll tell you what your discharge CFM and what your actual suction CFM are based on all your loads and everything and your design parameters. And it'll let you pick a what separator it thinks and it'll give you a list of alternative separators.
Yeah, so there's actually a part in there that you can actually set it up for like refrigeration, You're using this separator for refrigeration, and it'll
Yeah.
basically give you a range of what you want because they know you're not going to run full load, full balls to the wall every single freaking time, right? So they're figuring out. That's why like a lot of the remodels like that we see, Kev especially because he does a shit ton of them. Sometimes they'll take a centrifugal separator and they'll downsize it because they know that basically whipping around that refrigerant at that certain velocity, like the original line, what you were telling me what the fucking lines were, Kev. What were they? What were they
So we took
originally and what they
we
tuned it
took
down to?
a bunch of 2 and 5/8 discharge lines. I think the rack had like 4 compressors, 4 big boat anchor 060s on it. And we changed a bunch of cases out, added some glass doors, took some load off, shifted some load from rack to rack. And then we ended up dropping the oil separator from 2 and 5/8 down to inch and an eighth.
Think about it. It's like a
And
fucking
then
garden
back
hose,
up
right?
and then back up
Yeah.
to 2 and 5/8 going out to
I
the
I I feel like I'm on planet Pluto right now. I honestly because honestly, the way you guys are talking, this is not the lingo that I use. Like I've never heard CFM used to talk about refrigerant in a pipe. I've never heard that until this conversation. Is that normal in rack refrigeration using CFM?
a lot of times, yeah. It's I mean
Really?
a lot of components are sized off CFM, like when we're like doing control wise, like we're controlling like the capacity of the rack. I mean, you could do horsepower, you could do BTUs, but like more than likely the best control you're going to get is using CFM because it's
And how do you
bigger.
calculate that? How do you calculate CFM in a discharge line or a suction line?
Well, I mean, if you look at the compressor, like if you use like the Copeland mobile app, it'll actually tell you what CFM the compressor is because
Oh,
all
okay.
the controllers that we deal with, they when making their decisions, they deal better with bigger numbers, right? So you could do, oh, it's a fucking 4D, it's a 20 horsepower, right? Well, if you give it a bigger number, the algorithm actually works a little bit better and controls a little bit better, and then it just makes better decisions based off of the bigger numbers that it can calculate with.
Mhm. So we're on the oil separator thing. It's been a while since I even looked inside of an oil separator, but there's one that has the basically the float inside, right?
Well, I
So
mean,
all
uh,
three float. So
All
there's
3 have a float? Okay.
all three can have a float. So
Okay.
there's what they call impingement style, and then there's centrifugal, which is like a screw, and then there's coalescent, which is a filtered that separates the oil. Now they could all have what they call a reservoir. So they could all have a reservoir at the bottom and no filter, or sorry, no float, and the oil just comes straight out of there and goes to a electronic oil float that on the compressors that feeds in. That we would call that a high pressure oil system. Now, every time you see a float, generally that's a low pressure oil system. So it's draining that oil into another vessel.
So it really depends on what the oil system is, right? So typical oil pots or oil, and I know fucking Jordan Schimmel's gonna make fun of me for saying this, but oil pot or oil level control, which is usually stuck on the side of the compressor, those are only allowed to have the Sporlan ones are only allowed to have a 90-pound differential from oil pressure to actual suction pressure, because otherwise it'll end up breaking the damn float. Okay. But a lot of our compressors now have the OMB, the OMC control, where it's a ported oil level control. So basically, it meters the amount of oil going in there a little bit slower. So there's no mechanical parts to actually break. It's essentially just a fucking solenoid. So it just opens up full bore and it just lets that oil go through. And that's the reason why we need either high pressure systems or low pressure systems. It depends on what the customer wants,
Yeah.
right? I mean, when we say centrifugal, when we say helical, when we say impingement screen, when we say coalescer, that's just the method that it's using to fucking break the oil away from the
I see.
refrigerant, right?
I see. Okay.
If you have a float, now you have to basically lower that pressure, because what's going to happen is the oil float's going to level up and there's no reservoir on there. So you need some kind of holding tank somewhere to go there. But there are some separators that are what we call turbosheds, which have a reservoir in the fucking separator. So there's no need to have a float. And then at that point, it would just typically go discharge pressure right in the compressor and be modulated by the OMB or the OMC, essentially the electronic control. You've probably seen them in the plasma centers for sure.
No, these are smaller type machines, man. These were like little condensing units. They weren't nothing major. Or
Okay.
maybe on some of the maybe some on yeah, you might be right. Like they just almost look like a hermetically sealed canister kind of.
Mhm.
Yeah. Okay.
Yeah. No, for sure. And then it has little 3/8 line. Sometimes instead they'll have like a little capillary tube that just turns on all the time.
Yeah.
Like it'll have a solenoid in there. It just puts
I'm as you're talking, I'm just kind of thinking back to that one I was telling you with the high superheat, and it did something similar to that. And I believe it had a solenoid in line with it.
yes. Yeah. So whenever the compressor comes on, it just automatically fucking goes full bore, right?
Yeah.
Yeah. So
Yeah,
you'll
interesting. So let me ask you this then. If you have a failure with your oil separator and the oil gets logged into the evapes, how are you guys bringing the oil back safely back to the compressor without drying the compressor out or bringing too much back at once?
well, Kev, you wanna answer this? How you bring the oil back if the separator is not separated the way it should?
Well, you basically, the easiest way is to shut the rack down for like a half hour. Just turn all the compressors off, let everything warm up, let all the valves open up, and just slam it all back on as fast as it can, and let all that velocity push all that oil that's in the system back up to the rack, and you just hope nothing explodes.
Well, think about it, Gary. Like if you don't have all that oil sitting down there, right? It's only going to come back with a high velocity, right? So
Mhm.
if everything's at 10, right, and you just fucking shut it off and turn it back on, you're barely going to have any velocity come back because the expansion valves are going to meter, right? But if you turn off the liquid line, pump down the whole system, have it shut down for half an hour to an hour, what's going to happen? Temperature is going to raise. So as soon as you open up that liquid line back up, the expansion valves are going to modulate, but they're going to be fucking wide open because the
Yeah.
superheat's going to be high at that point, right?
Yeah.
It's going to just fucking bring that velocity back up. So that one particular instance where I told you where they took the 40,000 BTUs off, well, basically what happened was that the guy would go there. He's like, man, I got 3 compressors that are down. I got no oil in the fucking separator. These 2 are basically just about to fucking shut off. What do I do? I was like, shut down the liquid line. I was like, wait for about 45 minutes to an hour. All the temperatures rise up. Turns on the liquid line back up. Now all of a sudden he's like, well, I got oil back. It's coming back. All the compressors are filling up. Holy shit. And then the oil separator, because now instead of running just fucking 2 compressors, now we run 5 compressors. So what's going to happen? Now the separator is going to do what it's fucking supposed to do, unless it's a different issue, right? That's just with a helical. Now, if you have a coalescer, if you have an O-ring that's fucking blown or the coalescing filter is fucking impregnated, you're going to have to fix that. You know what I mean?
Yeah. Yeah, so I'm gonna give you a way that we use, or this one particular machine that we did something similar with it. This was a 15-ton carrier condensing unit on a roof, 5 stories above the evaporator, and
Mhm.
we always had a lot of oil return problems with this thing because it had an unloader on it, mechanical unloader. So, when it was in the unloaded position, obviously, it's not moving as much refrigerant around and bringing the oil back, and we'd have oil failures all the time. And the way we would get it back is obviously we would get it to load up fully and sometimes have to block a portion of the condenser to drive the discharge up just to get that refrigerant moving, and then we'd eventually bring the oil back. We had to end up putting an oil separator on that one, and we also had to put an accumulator, suction line accumulator, because compressors kept getting banged up. These were O6Ds in there, Carlisles, they were getting banged up. Valves were getting crushed and everything, and this thing was problematic, and the way we fixed it was, like, oil separator and suction line accumulator, and even still after that, we were getting a lot of shit coming back, and
Mhm.
it plugged up the screen and the accumulator, then we were having oil return issues again because we couldn't get the oil through the accumulator at the bottom because that screen was plugged up with crap.
Damn,
So,
I've
that
I
system was dirty as shit.
yeah, yeah.
I've only seen one other accumulator plug, and it was on that CO2 rack. CO2 rack. And let me tell you, that was bad. We were logging like 20 to 30 gallons of oil in this accumulator. Like,
So, Gary, there's a post on the supermarket refrigeration tech talk. There's a page that I'm an admin on, and like basically there's a like someone showed a picture of the sight glass, and it was
Mm,
fucking green. It
yep.
was green. And someone asked me, they're like, "What do you think's wrong?" I was like, "It looks like someone put fucking dye in it." And then the background you could see of the picture the kid took, there was like fucking 10 empty cylinders. The kid pulled out
two
105 gallons of fucking oil.
those were
Wow.
2 of my guys.
Was it really?
Those were 2 of my guys. It was an in-house store tech, and they were having K temp issues, and they were looking around. He threw his gauge or a probe on the coffin case, and it was squirting out oil on the suction. And the call literally said, "When you go there, you're probably gonna have to add 3 gallons of oil to the compressors."
That's
Look,
funny.
it's been doing it for months. They drained out like it was. They filled up 255-gallon drums in the bed of a pickup. They were pumping it out with a. They were bringing it into 5-gallon buckets and then pumping it from there downstairs with a like a glycol pump into 55-gallon drums in the bed.
Wow.
We were there
That's
for 2
crazy.
days draining oil out of this thing.
Hold on. I have actually, hold on, I have the pictures.
But we had a brand new accumulator. I mean, this was like a 8-foot tall accumulator by like 2.5 or 3-foot round. I mean, I think it was like a 600-pound accumulator, like full wise. We had one of those, the dip tube plugged up in it, and God, it's still they still have not fixed it. And
Look at
it
that.
went on 2 years now.
Gary, that looks like fucking dye.
Yeah, it was green just because there was too much oil in there?
It's all
Fucking
oil.
A. Hold
Wow.
on, let me bring up the other picture.
All the liquid was saturated with oil, like, at that store, like, you pop the liquid line, and it was just full of oil.
So you can see, so this is before when they had like when they first went there, right? And this is after removing 70 gallons, so it lightened up a little bit. And I these after running 101 fucking gallons.
Man, this stuff like this happens in our trade all the time. I know, the stereotypical old school guy with his hand on the suction line. I've seen units overcharged by like 40, 50% because they just keep going back every year and jamming gas in when there's a plugged up filter dryer instead of finding the plugged up filter dryer, just jamming gas in it. And the things are going off on high head in the mid and on in heat waves in the summer. Right?
No.
I know one guy, he was yelling at the apprentices because he says they didn't clean the coils properly, but they were spotless, but he was jamming gas in every friggin' spring.
Well, look, like here. So this is what Kevin was talking about. So this particular system had a float on here, right? You can see
Yeah.
all the fucking metal all up in here, right? So it blocked the freaking hole, which didn't allow the oil to go to the compressors. So what does someone do? jam some more fucking oil in the compressor. That's it. That's what you're supposed to do, right? So yeah, so this
Crazy.
is, I guess this is the end result. This is fucking system.
I wonder. I'd like to see the invoice trail for the oil that was picked for this thing.
Well, you know what? So what? POE oil right now is what? It's 140 $140 per gallon. Is that what it is, Kev?
65.
Holy shit! Holy shit! So times that by 101 gallons. So they spent what? Fucking what? Like 12 grand? No, 106. I don't know. 16 grand just fucking well just to remove it, right?
Well, then you got to dispose of it too. Like you get rid of a gallon or two, it's 55 gallon, or that's 110 gallons now. So, I mean, now you got to take it to somewhere that's going to dispose of it. You can't burn it like you could mineral oil.
You can still burn it.
No, you burn POE oil, it's nasty.
Well, so if you burn it, what you have to do is you actually have to dirty up the flame. So the polyol, whatever the hell is in there, it's synthetic, right? So it burns. It actually, if you burn that oil, it's very, very light. I used to do industrial compressors, Ingersoll Rand, and they used synthetic oil. And so like we had an oil burner in the shop, and like I had this like literally dirty up the flame because the flame was so bright and light that the photocell on the fucking oil burner wouldn't even pick up the flame. So the oil fell constantly. So I had to kill the air to it to make it actually work right.
Hmm. So you're saying back in the day, people would take this a bucket of mineral oil and just burn it and get
Oh,
together.
Yeah.
Yeah.
Waste oil burner.
Really?
Like the old guy, like
Yeah.
he used to do it in his garage all the time. I'm pretty sure he still does it with POE oil, but like it like obviously it's degassing refrigerant. That's probably not good, but
You
like I
gotta
mean,
let it set for a little bit.
Yeah. I mean, yeah, a bucket like that is going to hold on to refrigerant for quite some time, right? Before
yeah.
before it
Yeah,
all
lots
boils out.
I mean, he'll burn it in his garage all day long in his like homemade oil burner.
And is that heating his garage? Is he doing something
Yeah.
productive with it, or just? Oh yeah, okay, all right.
Yeah, he's heating his garage with it. So in the wintertime, and he has a waste oil burner that he like modified, and he runs refrigerant oil through it or car oil.
Kev, you cheap fucker. I'm surprised you don't have an oil burner fucking burn a minute roll and fucking POE oil there.
My wife not be okay with.
You got insurance just in case. It's fine.
Yeah, interesting topic because I haven't got into oil separators in this depth of a conversation with anybody before. So very cool stuff.
Nah, man, it's weird. So like, there's so many aspects to refrigeration. Like, people most of the time are limited to like, oh, it's superheat subcooling. That's it. There's so much more shit that goes into this. You know what I mean? And we just scraped the surface of all the stuff that we deal with on the regular. Fucking some of the VFD shit.
Now, do you think this stuff is like? Do you think that things are being over-engineered nowadays? Do you think there's too much going into it and too much things that can break and too many problems that can arise? Because it's happening in the HVAC side too, where it's like, why did they do this much stuff to this machine?
Let me put it this way: my washer and dryer are the conventional front load and top load.
Yeah,
I don't go with the fucking with the front load both washed because the more, man, I get it. Like they're trying to be more energy efficient, but the more electronics is, the more stuff can go bad, right?
mm-hmm.
I had a bitch of a time just shopping for a fucking refrigerator.
Yeah,
I mean, it's everything we work on, like all the CO2 stuff. They're pushing it all. Like, I mean, stuff's not where it needs to be yet. It's just overly complicated, too many safeties, and I mean, everything is just like they're overly complicating equipment that doesn't need to be overly complicated.
Yeah, CO2 is one of those things where you're basically, when you hit transcritical load, you're basically manipulating the pressures in order to get the refrigerant to do what the fuck you want.
yeah,
And that's a whole other conversation. So sorry, but yeah.
yeah. That'll be another can of worms. Yeah, so I mean, I see it all the time on this end of things, commercial, residential, even like the heat pumps and the ductless. I mean, it's getting very smart. It's getting very efficient. I mean, for the most part, I see a lot of this ductless and VRF stuff being very reliable, and I've done a lot of VRF and I've done a lot of ductless through my career, installed it, serviced it, and I've seen it be very reliable on that front. I'm just wondering how it is in refrigeration. I know, like, with when it comes to blower motors and stuff, with undersized duct systems that can cause more static with less airflow, we can heat up electronics more, like on an ECM motor and stuff like that, and we're seeing failures in that way. So I just don't know if you guys are seeing it on your side where things are failing because of the electronics involved these
See,
days.
we have the opposite. Like we have the ECM motors going and everything, but they're submerged in water all the time, or
Mhm.
they're cold, hot, cold, hot, cold. Every time they go into defrost, it's 85, 90 degrees, then right back down to minus 20. You know,
See,
constantly. So, I mean,
see,
ECM motors, they've gotten a lot better. The older ones were horrible and didn't last long. The newer ones, like I mean, a lot of the rescue motors and stuff, those things are bulletproof.
so the problem is that you have condensation, right? If you're
Yeah.
going quickly from a hot to cold, the dew point changes, and then
Yeah.
basically you have a lot of condensation there.
Yeah.
And we deal with that in boxes a lot of times because a lot of these, if you ever went into, I don't know what fucking supermarkets you have up in Canada, but like you have Costco's and BJ's and stuff, and a lot of
We
times,
got Costco's, yeah.
yeah, yeah. So they have a lot of times the coolers that you fucking walk in. Well, those doors have to be set up fucking just perfect because of the way the dew point runs. And what essentially happened now, if you take a wet bulb calculator, if you're running a saturated of like 18 degrees, right, and your dew point and your actual relative humidity of the box is like 50 degrees, your dew point is like 27 degrees. Well, if you're operating in an 18-degree saturated coil, that means it's 18 degrees. Well, dew point, right? What's the definition of dew point? Dew point is the temperature at which below the temperature will fucking start to condense. So if your coil's at 18 and your box temp essentially has a dew point of 27, it's gonna whatever surface that coil is fucking touching is gonna cause to condense, which cause
Mhm.
liquid to drip off the bottom of the evaporator, which cause liquid to fucking form on the floor, and then people get pissed.
Yeah.
So I don't know. I don't know about you, but like I know Kevin and I are real big numbers based. Like we what did you get for this? What did you get for this calculation? Like we're constantly running shit back and forth with each other, just trying to figure out issues, right?
Yeah,
And
I mean, I don't use calculations that much in my line of work. It's because mostly what I see are electrical failures and
mhm.
not problems like you're speaking about with condensation coming off of apps and stuff like that. So, but I mean, I'm starting to deep dive a little bit more into that stuff, into a little
Mhm.
bit more because when you're in school and you sit there in class and they're giving you all these calculations and formulas, you're like, when am I going to use this in the field? Like that's the attitude that most kids have, and I had it, I'm not gonna lie, I had it. And now I'm seeing that the value in knowing that stuff and where and when to use it to find out what the hell is actually going on with a problem.
You don't need a license to do anything HVAC related.
So
That's interesting.
it was weird when I moved to Connecticut. Like I had like I'd been in the field for 8 years, but I had to go through an apprenticeship. So I went through one semester of HVAC school, and the instructor's like, "You got an electronics degree, you'll be fucking fine." And then I moved to Connecticut, and they're like, "You need to go through school." So I literally had to do like an online HVAC school in order to go through an apprenticeship. But I'd been doing this shit for 8 years, and then I came to Texas, and they were like, "Oh, what's your social security number? Here's your fucking card." I'm like, "Cool."
Yeah, so what's good about that up here is every single province in Canada, as far as I know, they have a program that you have to go through. I think some even might be 4 years, but here in Ontario, we're 5. But once you get that certificate, it's called a red seal, and it's transferable between the provinces.
Well, that's like how kind of like industrial is. Like
Yeah.
industrial, like if you're working on like ammonia, you have to essentially be an operator. So
Mhm.
you have to go through the RETA classes and stuff like that. I know Jeremy Williams does a really good program that he does for his arts, his industrial program. But yeah, I don't know, man. Every area is different. It seems like the more unionized areas require more. Like so, you're talking like big cities. So Chicago have big unions, big union. Philadelphia or Philadelphia, whatever the fuck you want to call it. Jersey, New York. New York's a big fucking union state. There is a union here in Texas, but it's I haven't touched it.
Yeah. Yeah, I've never experienced a union. I've always been non-union, so I can't really speak to what it'd be like to be in one. I just know it's a touchy subject when a non-union and a union tech get together and start bashing heads over that subject, right? It can get nasty. I've seen it.
I don't understand that. Like
Neither do
someone
I. Yeah.
someone asked Kevin when we first started doing the podcast, the guy's like, "Well, how do you guys work together?" Well, what do you mean? He's like, "Well, you work for different companies, and like Kevin's union, and you're not." I'm like, "So
That's
fucking
funny.
what, dude?"
Yeah, some people are, I don't know. That's the internet for you, right?
Yeah. So
Anyway, guys, I appreciate the chat tonight. I gotta run myself. I am bagged. Like I gotta get to bed soon. So I really appreciate your time and as far as the misunderstanding with that group, man, that's you can post there anytime you want. Like I don't give a shit because I don't even go into that group anymore, really, because of how asinine it got with the trolls and everything. I'm like, I want to get rid of this thing. And I was telling you through messaging last night, you literally have to get rid of every single person in the group
to get
and
rid of a group,
delete yourself last, and that's when your group is gone. And
no
I'm like,
shit.
there's no way I'm doing that. That's going to take me weeks to do that. I'd have to stop adding people in and then just delete a few every day. I'd be at it for days, weeks.
Well, no, and like I said to you before, like I was like, because I talked about a year ago, when we first started building up, I texted you, I was like, "Hey Gary, do you mind if I fucking post your group?" Oh yeah, whatever. And then I would post, and I would get fucking denied or deleted. I'm like, well, what the fuck? You said I could. Like, what happened?
It might. Well, I would guess that the mods that help me, the moderators, they probably are like, okay, well, he's got a podcast. He probably wouldn't want this podcast. That's the only thing I can think of. The only one I've told them in the past was a long time ago. There's a guy, I can't remember his name. He calls himself J Dub Moneymaker, I think. You heard of this guy? He calls himself J Dub Moneymaker, and he has a podcast, and he has these cheesy kind of posts that promote his training classes. He's one of these sell guys. You know what I mean? And he goes around the states and he holds these classes and he charges like $2,000, $3,000 a person to go to these classes.
I want to do that.
And but it's to sell. It's like that Grant
Sell
Cardone.
a contactor, sell a new unit.
Yeah, it's sell. It's all about selling, no matter what the fucking problem is. Just sell them something before you leave the fucking house.
Yeah.
Right. And that's the only guy I told, and he calls himself J Dub Moneymaker. And you're recording this. You should probably turn it off.
All right, guys. Well, hey, listen, Gary, man, thanks a lot for being on, and have a good night.